Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 21 video on the chapter of mensuration where I will solve the remaining problems from 21 to 24 of exercise 20D. These problems are based on the area of a triangle. If you have not watched the previous 20 part videos on the chapter of mensuration, then I strongly suggest and request that you please also watch them to maintain the continuity of your study on the chapter of mensuration. This video is part of the playlist CBSE Maths for Class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 21 video on the chapter of mensuration, where I will solve question number 21 to 24 of exercise 20D from the chapter of mensuration. Okay, so on the right hand side I have written down all the questions along with the answer so that I can match my solution, and on the left hand side I have kept as a reference the related formulas based on the area of a triangle. Okay, so the problem number 21, so there is a figure. It says ABCD is a rectangle with length 36 centimeter and breadth is 24 meter. In triangle ADE, EF is perpendicular to AD. EF is perpendicular to AD and the length of EF perpendicular is 15 meter. Calculate the area of the shaded region, that is the polygon DEABC. We have to find the area of the shaded region. Okay. Now, the easiest way to solve this problem is that we will not find the area of the shaded region, but we will find the area of the triangle ADE and subtract that area from the area of the entire rectangle ABCD. Okay, so let's try to find the area of triangle ADE. So area of triangle ADE is equal to, applying the formula half into base into height, we can consider AD as the base and FE as the height. Since FE is drawn perpendicular to the side AD, we can consider AD as the base and FE as the height. So half AD into FE. Okay, this is equal to, what is AD? AD is the breadth of the rectangle, which is given to be 24 meter, and FE is given to be 15 meter. So this much meter square is the area of the triangle ADE, which is equal to 12 multiplied by 15 meter square, and which is equal to 60 and 12, so 180 meter square is the area of triangle ADE. Okay, and what is the area of rectangle ABCD? We can easily find the area of the rectangle ABCD from the formula product of length and breadth. So this will be AD multiplied by AB, which is equal to, AD is 24 and length is 36, this much meter square, and this is equal to 20, okay, so 144 and then 72, so 864 meter square is the area of the entire rectangle. So this implies we can say that area of shaded region will be equal to area of the rectangle ABCD minus area of the triangle ADE. which is equal to 864 minus 180 this much meter square, which is equal to 4 and 8 and 684 meter square is the area of the shaded region. Okay, let's do the next problem. Question number 22. There is a figure. It says ABCD is a rectangle with AB, that is the length, is equal to 40 centimeter, and BC, that is the breadth, is equal to 25 centimeter. PQRS are the midpoints of the side CD, BC, AB and AD, okay, respectively. Find the area of the shaded region. Find the area of the shaded region. Okay, so whenever you have a rectangle, always remember that in a rectangle, if you join the midpoints of all the sides, the quadrilateral form, which in this case is PQRS, it will always be a rhombus. So PQRS is a rhombus. Now also I can use the formula of a rhombus. I can also use the formula of area of a triangle, because the shaded region, if I join PR, PR will be equal to BC, will be equal to DA, and how will I know that? And also if I join PR and SQ will be the diagonals of the rhombus PQRS, and they will definitely bisect each other at right angles. So I think for this problem we can easily apply the formula of area of a rhombus, because the PQRS will be a rhombus, as PQRS, the quadrilateral PQRS, is formed by joining the midpoints of all the sides of a rectangle. Okay, so area of rhombus PQRS, we know the area of a rhombus is half multiplied by the product of the diagonals. So half multiplied by the diagonals of the rhombus PQRS are SQ multiplied by PR. This is equal to half. Now what is SQ? SQ is parallel to, SQ will be the diagonal SQ is parallel to the sides of the rectangle DC and AB. So SQ will be equal to AB or DC. So this is parallel to this and this, and this diagonal will be parallel to AD and PC. So we will always have, okay, so this is SQ. Now what is SQ? SQ is equal to AB. And what is PR? PR is equal to AD. So this is equal to half. AB is given to be 40 centimeter, and AD is given to be AD or BC is given to be 25. So this much centimeter square. This is equal to 20 multiplied by 25 centimeter square, and this is equal to 500 centimeter square. So this is a very important concept. You must always remember the quadrilateral formed by joining the midpoints of any rectangle is always a rhombus. Now if is a rhombus, now if the rectangle, instead of rectangle, if it is a square, then if ABCD was a square, then PQRS would have also been a square. Let me quickly check that. If yes, I think so. If ABCD was a square, then the quadrilateral PQRS, it would have also been a square. Okay, let's see the next problem. Question number 23. There are two parts. Find the area of the shaded regions. Okay, so in both the parts, as you can see, the entire figure is enclosed in a rectangle. In the first part, in part 1, the dimensions of the outermost, the enclosing rectangle, that is ABCD, are given. That is the AB is given as 18 centimeter and the length is 18 centimeter and the breadth is 6 centimeter. We have to find the shaded region. Now, as you can see, it is more easy if you see the empty region, that is the region, the empty region, that is the region which is not shaded, that region, the white region is formed of two triangles, DFE and EBC. So if we find the area of those two triangles, sum them up and then subtract that area from the entire rectangle, we will get the area of the shaded region. So let's say just for the sake of understanding and visual understanding, let's say this figure, this triangle be A and this shaded region be B, not ABC because they are already used. Let's say this be P, the triangle DFE, let's denote it by P figure, and the shaded region be Q, and let's say this be R. Okay, R. So in part 1, clearly we can say that the area of Q, what is Q? I'm just giving a name to the shaded region, Q. So the area of Q will definitely be the area of the entire rectangle ABCD, the area of ABCD minus the area of the figure which P, which is a triangle, minus the area of the figure R, which is also a triangle. Okay, now we have to find the area of the rectangle ABCD and area of the P and R. Now what is okay? So what is area? What is area of P? What is P? P is nothing but the triangle DFE. DFE. Can we find the area of the triangle DFE? Yes, we can, because you can easily see from the given dimensions. We can easily find. So what will be in triangle DFE? We know this angle is right angle. So we can consider DF as the base and DE as the height, and both the dimensions, both the length of DF and DE are given in the figure. So this is equal to half multiplied by DF is given as 6 centimeter and length of DE is given as 10 centimeter. So this is this much centimeter square, which is equal to 30 centimeter square. Okay. What is R? R is also a triangle. R is the triangle. So area of R is equal to area of the triangle EBC. EBC. What will be the area of the triangle EBC? We know that this is the right angled, so we can consider EC as the base, and BC as the height. So this is equal to what is EC? What is EC? EC is given to be 8 centimeter. So 8 multiplied by BC. BC we know is the breadth, that is 10. So 10, this much centimeter square, and this is equal to 40 centimeter square. Okay. And finally, we need the area of the rectangle ABCD. Area of rectangle ABCD is equal to length and breadth, which is equal to 40. What was the breadth? 6. So 18 into 6. 18 into 6. This much centimeter square, which is equal to 108 centimeter square. So this implies area of shaded region, area of Q, or area of the shaded region, which I have visually represented with the letter Q. Area of shaded region Q will be equal to now area of ABCD, which is 108 minus area of P. Area of P is 30 and area of Q is 40. This much centimeter square, which is equal to I guess 70. Okay, so 38 centimeter square is the area of the shaded region, and my answer is wrong. My answer is wrong. Okay, let me see. I think I have done a calculation mistake. 110 centimeter square. Okay, let me see. Area of P is area of P will be equal to area of triangle DFE, which should be half into 6 into 10. Okay, so this is 30 centimeter square. Okay, area of R is area of triangle EBC, which is half into EC into BC, and EC is 8 centimeter and BC is 10 centimeter, so 440 centimeter square. Okay, and okay, and what is area of triangle ABCD? Area of triangle ABCD is not 6. See, 18 is the length and the breadth is 10 centimeter. So I did a mistake over here. This should be 10, and this is 180. This is 180. So 180 minus 70 is 110 centimeter square is the area of the shaded region of part 1, and I have no space left for part 2. Okay, what will I do? I will have to rub the solution for part 1. So if you think you can pause the video and take a screenshot of the solution for part 1, as I have to delete it because I have no space for solving part 2. Sorry for that. G, I am deleting the solution for part 1. Okay, let's solve part 2. Now in part 2 also, as you can see, the shaded region is a triangle, but it will be difficult. We do not know the dimension of we do not know what will be the base and height of the triangle of the shaded region. Let's say this region B, shaded region, this B, let's say A, and let's say this triangle, this white triangle be B, and this be C, and this be D. So there is no easy way that we will know the base and height of the triangle A, that is the shaded region, but we can easily find the base and height of the other triangles, that is BCD. So we can easily find the area of the triangles BCD, and then we can subtract their total area from the square. The enclosing figure is PQRS, which is a square. Okay, so area of the shaded region is A. Area of A is nothing but area of the rectangle or square ABC, sorry, not ABCD, PQRS minus area of the triangle B minus area of the triangle C minus area of the triangle D. Okay, let's find the area of PQRS, the square, and the area of the triangles BCD. So area of PQRS, which is a square, is obviously side square, that is 10 square centimeter square, which is equal to 100 centimeter square. Okay, area of the region B, which is the triangle area of the triangle SLR is equal to half. We can consider SL as the base and SR as the height. Now what is SL? SL is given to be the area of the square PQRS will be 20. The length of each side of the square PQRS is 20. So this is 20 and this will be 400 centimeter square. Okay, So what is the area of triangle SLR? It is half into SL. What is SL? SL is 10 centimeter. And what is SR? SR is 20. So this much centimeter square, which is equal to 500 centimeter square. Area of C, area of the region C is nothing but area of the triangle LPM, which is equal to half. We can consider for the triangle LPM, we can consider the base as PM and the height as LP. So this is equal to half multiplied by what is PM. PM is given to be 10 and LP is also 10. So this much centimeter square, which is equal to 50 centimeter square. And finally, what will be the area of the region D, which is the triangle, which is equal to the area of the triangle RMQ. RMQ is equal to, we can consider MQ as the base and RQ as the height. RQ as the height. Okay. So this is equal to, MQ is 10 and RQ is equal to the side of the square. So 20. This much centimeter square, and which is equal to 500 centimeter square. So this implies now the area of the shaded region, which is A, area of A is equal to, area of the square is 400 centimeter square minus area of B is 100 minus area of C is 50 and area of D is 100. So this much centimeter square, which is equal to 400 minus 250 centimeter square, which is equal to 150 centimeter square. So the area of the shaded region, which is the region A in part 2, is 150 centimeter square. So whenever you have to find this kind of shaded region, which is a rectangle or even triangle, and if you can't figure it out, what are the dimensions, the required dimensions of the triangle or the rectangle to find the area, you will please note that you can always find the area of the shaded region by finding the area of the non-shaded region and subtracting that their total area from the enclosing figure. That is, it could be a rectangle or square or any other quadrilateral or maybe any other polygon. Okay, let's do question number 24. Find the area of the quadrilateral ABCD. So ABCD is a quadrilateral where BD is a diagonal. BD is given to be 24 centimeter. AL is perpendicular to BD and CM is perpendicular to BD. AL is 5 centimeter and CM is 8 centimeter. So we can easily find what will be the area of the quadrilateral ABCD. So area of ABCD, area of the quadrilateral ABCD is nothing but area of the triangle ABD plus area of the triangle BDC. Okay. So what is the area of triangle ABD? We know in the triangle ABD, AL is perpendicular to AD, AL is perpendicular to DB. So DB can be considered as the base and AL as the height. So this will be BD multiplied by AL. Plus we have area of triangle BDC. In triangle BDC, CM is perpendicular to BD. So we can consider BD as the base and CM as the height. Okay. Now if you do the addition, you will see we will have BD by 2 common. So BD by 2, if I take out BD by 2 common from both these terms, this will be now AL plus CM. So now we know the value of we know the length of BD, AL and CM, and we can easily find the area. So BD is given to be 24 by 2 multiplied by AL and cm are given to be 5 plus 8, this much centimeter square. This is equal to 12 multiplied by 13 centimeter square, and this is equal to 36 and 12, 156 centimeter square. Okay. So with this, it comes to an end in solving the remaining problems of exercise 20D. So I have solved all the problems of exercise 20D, which were primarily based on the area of triangles. Now, based on all the formulas and concepts that I have discussed so far from the chapter of mensuration, that is the square, rectangle, rhombus, parallelogram, and triangle, and their related concepts. I have prepared a chapter concept problems set number 3. The link of the PDF will be there in the description below. There are 6 problems. Try to solve them yourself. I will provide the solution in the next 24 hours. So the next video will be the solution of the chapter concept test, chapter concept problems set number 3, which will be provided in the description in this video. And after that, I will start discussing. I will start the discussion of the area of a circle and circumference. So these videos are coming soon. So please stay tuned. I will end the video. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.